This is a video on maximizing volume. The question states, the cost of building the floor and the roof of a rectangular building is twice the cost of the side walls. Find the dimensions of the building with maximum volume that can be built at a fixed cost C. So let's start by sketching a picture. We have a building that's rectangular. So I draw my rectangular building with side lengths x and y and height z. And the volume of this building will be x times y times z. So for the cost, I have the top and bottom of the building, the floor and the roof, and those each have area x times y. And then I have the front and back, which have each area x times z, and the left and right, which each have area y times z. So I can say that the cost, C, is twice 2xy, because the xy, that's the floor and the ceiling, those are twice the cost of the other side, so I put the 2 in front. Then I have the front and back, 2xz, and the left and right, 2yz. So now let's solve for z. I can subtract 4xy and divide by 2x plus 2y. And I get that z is equal to c minus 4xy over 2x plus 2y. I can substitute that into the volume equation, and I get v equals xy times c minus 4xy over 2x plus 2y. And I want to maximize the volume. So in order to do that, I take the partial derivatives with respect to x and with respect to y and set them equal to 0. I'm going to spare you the details on finding the partial derivative. It's pretty much a product rule and a quotient rule for each of these, and then simplifying. What I got was that v sub x is negative 4x squared plus 8xy minus c, all times y squared, over 2 times the quantity x plus y squared equals 0. And that v sub y equals negative 4y squared plus 8xy minus c, all times x squared, over 2 times the quantity x plus y squared, and that is set equal to 0. So if a fraction equals 0, then that means the numerator equals 0. And also y can't be 0 because that would give you 0 volume, and x can't be 0 because that would also give us 0 volume. So that means that the inside of the parentheses of each of these is equal to 0. So if I subtract one from another, then the 8xy and the minus c's will cancel, and I'm just left with 4x squared minus 4y squared is equal to 0. So if I add 4y squared to both sides, divide by 4 and take a square root, I get that y equals x. Notice I don't worry about plus or minus because this is a building and it can't have negative sides. So now I can plug in to 4x squared plus 8xy minus c equals 0, and I get 4x squared plus 8x squared minus c equals 0, or 12x squared equals c, or x is equal to the square root of c over 12. So since y equals x, y is also the square root of c over 12. And I can plug x and y in, and I get z equals c minus 4 times root c over 12 times root c over 12 over 2 times root c over 12 plus 2 times root c over 12. I can simplify that up, and I got that z equals the square root of c over 3. That's a bit of algebra, but I worked that out, and that's what I got. So now I'm ready to state my conclusion. I can conclude that in order to have a maximum volume, the building should have a square root c over 12 by root c over 12 base and a height of root c over 3. And I'm done with the problem.